All right, good morning. I want to talk about what I went over yesterday during the health session, and I have that recorded. We can always circle back to those topics if we like. These are the test topics that you'll be expecting to see tomorrow. I'll share this during class as well. So power rule integrals, right? We saw this on the quiz, and we've been practicing with those, especially like fractions where there's only one term in the denominator. We can split up into individual fractions and take care of each term and go through power rule. Use substitution, change your variable. We'll go through some of that today in class on page 3 and 4 of our test review. Trig integrals, definite integrals involving potentially unit circle values. So we can go over one of those problems as well in class as well. Definite integrals involving absolute value functions. We went over that as well yesterday during the help session where we have to sketch the graph out. Right, sketch out the absolute value function, and then figure out the end intervals, and then just figure out the dimensions of the triangles and add them together. Right, we practiced that in class as well. Even and odd functions. Hey, we did that yesterday. And I'll go over, second fundamental theorem of calculus, average value theorem, and then this we saw on the quiz as well. Given second derivative, find f of x, or another variation would be given acceleration, find x of t, find position. So we take the antiderivative from acceleration to velocity. If there's a order pair we can plug in, we solve for c. We take the antiderivative again to get from velocity up to position. We saw that variation on the quiz, and we expect to see that on the test as well. Okay, so maybe let's start with, let's do even and odd functions again, and we'll go through 6 through 9, and then we can circle back and do some of the other ones if we want to. Okay, so if you guys get a sheet of paper, I'll just create some problems for us. Okay, so let's say the integral from Okay. So as review, the first thing we do is we identify the shortest or smallest interval, and we start there. Okay. So which one is the smaller interval that we can start with? Yeah, this one, right? Not because we're looking at these numbers here, but because we're looking at the span of the interval. Now, we want to put this on the graph first, but do you notice anything that is a little bit off about this? Yeah, so anytime we want to try to put anything on the graph, we're trying to visualize anything, we prefer to have the lower bound being the smaller value. So we're going to force this into something that's a little bit easier to graph. We're not changing anything, we're just making it so that it's more straightforward. So we know the integral from 2 to 4 must be equal to what? -3. Okay, so let's sketch that portion there. We know that this is an even function. So our graph is going to be reflected over the y-axis. We're expecting mirror image. Okay, so from 2 to 4, we want the graph to show -3.
Carmen Holt, please come back to the front office. Carmen Holt, please come back to the front office.
Now, as soon as we put any property down, we want to go ahead and fill out the property on the other side. Okay, so before we even get to the larger interval, what can we know about the other side if it's an even function? Same. Okay. Good. -4 to -2 is also going to be -3. Good so far? Okay, next up. Graph the remaining property. So the remaining property is from -4 to 2 is equal to -2. So what we want then is we never want to overlap, right? I think the tendency is we want to just go from -4 to 2 and just say this whole thing is equal to -2. But then we're overlapping with something that we already have. So we don't want to overtake this. Rather, we want to just fill the remaining spots so that these values adds up to be -2. So we know all this is going to add up to be totals to be equal to -2. So what can I put in this spot so that -3 plus what will give us -2? 1. Okay, we know this whole thing is 1, but can I split it? Can I split it evenly? What would that be? 0.5 and 0.5. Let's double check. -3 plus 0.5 plus 0.5 is equal to -2. All right, so we're really not graphing this whole thing here. We're really splitting it up so that the regions and the mounds that we create adds up to be -2. Okay, does that make sense? Okay, so now we can total what it's asking us to find. We want to find the definite integral from 0 to 4. So from 0 to 4, we can total this up. -3 plus 1/2 will be -2.5. Okay, any questions with part A? Okay, part B. Now let's say our function is odd. And now I'm going to ask us to find the definite integral from 4 to -2. Okay. All right, same thing as before. We're going to target the smaller interval first. All right, target the smaller interval first. 4 to 2, we already made that adjustment. That's really 2 to 4 with the regions below the x-axis. Okay. Okay, but now we want an odd function. Well, let's see. Let's get this out on the paper first. From 2 to 4 equals -3. Right, go with that. That's the same starting point as what we did from before. Right. But now, as soon as we have something down on paper, we want to try to go ahead and fill out the other side. All right, we want now an odd function. So what can we put on the other side? Okay, are we good with that? Okay, so now we can move on to the other interval, other property, from -4 to 2 is equal to -2. It's equal, so we know that this whole region is going to total to be -2. All right, so this is 3. Then what do I need here so that I can add the two numbers to give me -2? -5. And I need to split -5 into 2 parts. So each of these will be what? -2.5. All right, this is -5. -5 plus 3 equals -2. Okay. All right, we have everything that we need in front of us. We filled out the entire graph. We want to find the definite integral from 4 to -2. Any adjustment needed here? Yeah. This is the same thing as the definite integral, the negative version of the definite integral from -2 to 4 of f of x dx. All right. I mean, we could just go look at this and realize, oh, I'm going to add this up and change the sign. Or you can get the bounds to be flipped and realize that you're really looking for the negative version of the definite integral from -2 to 4. So from -2 to 4. This is -5 minus 3, which is -8. So therefore, the negative version of -8 must be equal to +8. Right, we know the definite integral is just totaling those values up, but really because of the fact that we changed the bounds, we have to include the fact that there's going to be a negative impacting the value. So negative of a negative will give us positive. Okay, any questions? So expect to be able to do something like this on the test. Okay, just be careful that if something is given to you where the bounds are not in order, go ahead and adjust that order so that you can get the signs to be correct. All right, no questions? You guys comfortable with this you saw this on the test? Okay. All right, next up, let's do a second fundamental theorem of calculus. It's really exploring the fact that if we find the derivative of an integral of a function, that a lot of those things will cancel out and we don't have to do a whole lot of work because we're kind of back to where we started. But there is a little bit of something that we got to keep track of. Okay, so here's the rule. If there was a constant here, then really the only thing that's going to happen is that this upper bound is going to get inserted into the function. But then this derivative is really going to pull and have an impact on this upper bound. So I know it's kind of strange here because you see that integral notation, but you're really not doing anything involving antiderivative. And the reason why is because that derivative notation is kind of undoing all the integral process that we normally would do. But then this derivative would still have an impact in terms of what it does to that upper bound. So this is what the second theorem normally would be. However, if there was a lower bound that was a variable as well, then we would have to include that value as well. And the way we include it is after we take care of the upper bound, we have to subtract involving the lower bound. Okay, so if the lower bound is a constant, you can ignore all this. But the lower bound is a variable, then we have to involve and repeat what we did with the upper bound. Okay, that makes sense. Okay, so let's see if we can do one of these here. Okay, so for this problem, will we need to involve the lower bound? No. E is a number, so that's a constant. So it's like as if we don't worry about the lower bound as well. It's only the upper bound because only a variable is going to last until the end of the problem. Okay, so we're really only looking at this piece right there. Okay, so f of p of x, all we're doing is we're taking that upper bound and inserting into the function. Wherever we see t, we just go ahead and replace t with root x. Okay, everybody comfortable with interpreting what to do using that notation? Multiplied by, what's next? Derivative, right? What can I do to get this ready for derivative rule? So 1/2. And now we go through power rule, right? Power rule says, for derivative says, bring the exponent down and then subtract 1 from the exponent. So no antiderivative going on, even though there's integral notation here.
Did you get the 30?
Oh, 5, yeah, 5, I misread. Yeah, I'm just copying everything. I should have copied everything from the previous portion. I'm just replacing the t with root x. So Power rule for derivatives. Is this, right? The derivative power rule, we bring the exponent down in front, and then we subtract 1 from the exponent. Right. So if it was 3x squared, it'll be 6x, right? X to the 1/2 will be 1/2 x to the negative 1/2. Right, so this is first semester, right? Not power rule for antiderivatives. It's not this. It's power rule for. So we basically have the answer though, but we're going to do a little bit of cleanup. You can distribute or not distribute. It's fine. I'm just trying to make it look a little cleaner. That's fine. If you want to go further, you can. Okay, either's fine. Okay, let's do another variation here. Sorry, it should be 2. So now what do you notice? There's a Q, that's right. There's upper and lower bound that both will be involved in this process. Before, we didn't have to worry about it. So we have to repeat the process with the lower bound as well. Once we do the upper bound, we do minus f of q of x times q prime. So f of p of x times p prime minus f of q of x times q prime. Try to clean up as much as we can, but don't do too much here. Yeah.
If we kept it in like the original form, that's still would be correct.
Yeah, that's fine.
We don't fully simplify
That's fine, yeah. Okay. All right, any questions with variations of second theorem? Okay. Okay, so next up, let's do an average value theorem. Okay, this is actually on the 4345 review, but I'll go ahead and put this on a separate sheet. Number 2 here. Okay, we have to know average value theorem. Basically, it's the definite integral which represents area. Area divided by the width equals the height. Right, so it's really just rearranging the area formula for rectangle and saying that height is equal to the area divided by the width. Okay, in case that helps you memorize the formula. So f of c is equal to, the area is the definite integral from a to b of f of x dx, and the width is just going to be b minus a. But we want the width in the denominator, so we typically push it out in front as a fractional value so that we're not having to stare at a complex fraction. Okay, area divided by the width is equal to the height. We know width times height equals area. We're just dividing that width over and then just rearranging that formula. Okay, so first things first, just go ahead and plug everything in, right? Your A and B values, that's your A, that's your B. Okay, we do a little bit of cleanup here. Pi over 4 plus pi over 4 will be 2 pi over 4, which is pi over 2. Okay, first things first. I know it's tempting to involve the pi over 4 into the expression, but we got to do the indefinite integral first, right? So do we recognize this? What's the integral of secant squared? Tangent, right? Again, hopefully we can also spend today reviewing the derivative rules, right? If we have all the derivative rules for trig written out in front of us on the test, we kind of look to see, oh, okay, there it is, my secant squared. Antiderivative secant squared must bring me up to tangent u plus c, right? Antiderivative is just starting on the right side of the derivative rule and moving your way back to the left. Okay, you know secant squared is going to be tangent. So we can now take the antiderivative and then involve the bounds. I'm going to choose to wait to do this at the very end. So upper bound first. Minus lower bound. Okay, so I want you guys to be able to recall your unit circle values. Tangent of pi over 4 is going to be 1. Tangent of negative pi over 4, right, this is going to be in the fourth quadrant. Tangent is negative in the fourth quadrant, so it's going to be minus a negative 1. So that's equal to 2. Okay. So this is the area portion. We still have to deal with the width portion. Now, 1 over pi over 2 is a complex fraction, right? 1 over pi over 2 is the same thing as what? Yeah, if I were to flip this fraction up, it really is 2 over pi, right? So therefore, my average height, average value, is 2 over pi times 2. There's my width component. There's my area component. Average height, average value is 4 over pi. Yeah.
If we choose to do, like, you involve the width at the end, but if we do like tangent with the upper bound and then multiply by width, tangent with the lower bound with the width, and then subtract those, would it still be right?
It would still be the same.
Okay.
You would be left with 2 over pi minus a negative 2 over pi, and 2 over pi plus 2 over pi will still give you 4 over pi. So either you involve the width along with the evaluation of your area of your definite integral, or you wait to the end. Either way, you just have to make sure you involve it sometime, either in the middle of the process or at the end. Otherwise, you'll be only left with the area, and you're not truly representing the average value. Okay, so let's do one more, and let's do a problem where it's like a PVA or particle motion problem, where I'm going to ask you to go from acceleration all the way up to position. Okay, so we're starting at the acceleration level. We're trying to move up our way to position. So we got to take the antiderivative how many times? Twice, right? Acceleration's antiderivative will bring us up to velocity, and then velocity's antiderivative will bring us up to position or x sub t. So let's set this up here. If I want to find velocity is going to be the antiderivative of this function, right? Now, how can I get this ready for power rule? Yeah, so square root of t is t to the 1/2. We got to push it up, t to the negative 1/2. Otherwise, we won't be able to do power rule. Okay, so now we do antiderivative. Okay, antiderivative is where we add 1 to the exponent and divide it by that new exponent. Plus c, right? Plus c, indefinite integral. All right, what can we do at this level? Yeah, 0 goes in for all the t's. 1, it gets entered in for the velocity. So I have my updated velocity function. This is my halfway point. But we're only halfway there, right? We got to take the antiderivative again to bring us from velocity up to position. So to find my position function, I need to once again take the antiderivative of this function here. Okay. Jump directly into power rule. All these terms are set up nice and ready for power rule. Add 1 to the exponent. 1/2 plus 1 is 3/2. 1 becomes 1x or 1t, and then another c is going to show up. Do some cleanup. Threes cancel out. Flip that 3/2 up as 2/3. 2/3 times 2 is 4/3. Okay, is there anything available for us to continue to update this equation here? Yeah. Okay, 3 gets inserted for position, 0 gets inserted for all the t values. All the 0 goes away, our c sub 2 is just 3. And now we can completely update our position function to be a specific equation. Okay, so between yesterday's review session and today's review session, I've kind of gone over all the major topics. We'll work through the test review worksheet today in class. Encourage you guys to work through the other video if you hadn't had a chance to. I think that would give you some additional practice. There's morning review tomorrow. The morning review is already attached to your packet, so work through that if you like. But we'll do this another help session tomorrow morning, 7:15. Okay. Thanks, guys.